when it's underneath. If they went when one is greater than the other, it's when it's over it. They're always referring to the output, the y. So let's see. So you've got this one. All right, let's try this.
Okay. So do we make it we want to find out x first, right?
Yep.
Okay. So when it says y equals 12 plus 4x, would you need to keep the y there? Y equals.
No. They're both equal to y, and so they're both equal to each other. And so this and this are both equal. And so you could say x squared is equal to 12 plus 4x.
Okay.
And you would solve that.
So could you minus 4x on both sides?
Yeah.
So it'd be x squared minus 4x equals 12. And then would you divide by minus 4 on both sides?
I would subtract 12 from both sides.
Okay. Which would make it x squared minus 4x minus 12 equals 0. Then could you put that into the calculator?
Yep.
Okay. 1x squared minus 4 minus 12. So x1 is 6, x2 is minus 2.
That's it. And so which is which?
X1 is 6 is P1 and the other one's P2.
Yeah. So that's 6. That's minus 2. And then part B.
So would you substitute x in for both?
Just by looking at the graph. So 12 plus 4x is the straight line, the black straight line,
yep.
Line 1. X squared is the red line 2. When is black line greater than red curve? For what values of x?
Was it 12 plus 4x?
Yeah, that's a black line. So for what values of x is the black line higher up than the red curve?
6.
Less than 6, bigger than 6?
Greater than 6.
Yeah, when x is greater than 6, and is there any other part? When the red line is higher up. No. It goes under the curve. So when is the red curve under the black line?
When it's minus 2.
There, the red curve is over the black line. At minus 2, they're exactly the same. So where is it that the black line is over the red curve?
As in like all the way at the top of the red curve?
So they're exactly equal to each other at minus 2 and 6. When x is minus 2 and when x is 6. Yeah?
Yeah.
See how in between those two,
yeah,
the black line is over the red?
Yeah.
So basically, it is when x is between minus 2 and 6.
Oh, okay.
If they had asked when is 12 plus 4x less than it, that would be on the outside when x is less than minus 2 or greater than 6.
Okay.
Yeah. So it's doing it graphically. So yeah, x is between -2 and 6. Tricky, tricky, tricky. Okay, let's try this one.
Okay. So do we want the first equation to equal to y first?
Yeah, you could do it that way, yeah. There's actually another way to do this. You could do it using simultaneous equations right away with the calculator.
Okay. So it'd be 3x x
Yes.
2y equals 6 and 1x minus 1y equals 5. So x equals 16 over 5.
Yeah.
And
So-
y equals minus 9 over 9 over 5.
Y equals, what is that? 1 minus 1.8. I'll just do them as decimals. Okay. So that's the coordinates of where they cross over. Question B.
So it would be written out as minus 1.8 and then is lesser than 3.2.
No. Where is the, so 2y plus 3x, that's the red line. So where is the red line greater than the black line? Where is it higher up?
When it's above 3.2.
To the left of 3.2.
It's on the y-axis.
We always describe it in terms of x. So how would you say to when x is to the left of 3.2?
It's
it's when x is less than 3.2, literally pointing to the left. So if you have this, let me just do a line, do a blue line. So they're exactly equal to each other when x is 3.2.
Yeah.
On the left of it, red is bigger, it's higher up. On the right of it, black is bigger, it's higher up. And you can sub in different values for x and y to get 6. Yeah, but basically when x is less than 3.2, you get a higher number for y.
okay.
When x is greater than 3.2, you would the black equation would give you a higher number for y.
Yeah.
Yeah, so you can do it by graphing it. Any questions there?
So was the answer x is greater than 3.2?
Less
So
than.
x is lesser.
Yeah. When x is less than 3.2. Yeah.
Okay.
Any questions there?
What is it like? I don't understand what it means by 2y plus 3x is greater than x minus y.
So you would have to solve that. If you have a graph, one way here you have 2y plus 3x. Is this right? Yeah, I think it's all right. So where? So this red line is the 2y plus 3x one.
Yeah.
Black line is the x minus y one. And so it's basically when is the red line greater than the black line, greater in terms of y, the output.
Oh, okay, yeah.
When does it have a higher up y coordinate? And that's when x is less than 3.2, to the left of 3.2.
Okay.
Yeah, it takes some getting used to. I had to think about it long and hard when I started doing it.
Mhm.
Let's see these ones. I just want to... Will they help me out? Well, they won't. Okay, this is what the exam question looks like. I just want to see, do they help me out at all with a graph? No, we have to do it ourselves. Okay, let's try this one.
A.
Yeah.
Okay. So would you write out as 3x minus 7 equals 3 minus x?
Yep.
And then you'd solve it. Okay.
Yep.
So you'd add x on both sides.
Mm-hmm.
So it'd be 4x minus 7 equals 3, and then you'd minus 3 on both sides, which would make it 4x minus 10 equals 0. Then would you put that into the calculator?
Yeah, you can probably just solve it yourself. It's up to you. Whatever I want to do.
So would you put it in as 0x squared, and then
You can do...
minus...
That'll work, yeah.
Okay. Minus 10. Well, it doesn't work because it says it's a math error because there's no x squared.
Ah, okay. Another way is to just put it in. What's the equation?
4.
Like what was it? How many x?
What do you mean by how many?
Like what was
the equation is 4x minus 10
So 4x
equals 0.
minus 10, and then you can do alpha calc for equals 0, shift calc for solve, and just pick a lucky number.
2.5.
2.5. And so x is 2.5. Let me cheat with my graphical calculator. Shift graphical solve, point of intersection. There we go. X is 2.5, y is 0.5. Oops. They wanted me to sketch the graph. Hang on. Capture screen. Will that work? Copy. There we go. They wanted me to sketch the graph. There, I sketched it.
Okay.
Question C. How do we use our graph to do question C?
Okay. So it wants when 3x minus 7 is greater than 3 minus x.
Yep.
So it would be x greater than... Would be x... No, would it?
Mm-hmm.
X is greater than 2.5.
Perfect. Do I have the answer? Yeah, x is greater than. So 5 over 2, 2.5, same thing.
Yeah.
That's what the graph looks like. Yeah, because it is to the right. That's when the blue one is higher up. To the left would be the red one. Any questions about that?
Nope.
Okay. So this one. And you can always just actually solve it. So you could do, instead of an equal sign, do a greater than sign. And instead of getting x equals 2.5, you'd get x is greater than 2.5.
Yeah.
But if you have a graph, supposedly you can do it more easily. I prefer calculating. This one, you have to. I want to cheat. Just do the bit that we need. Okay, so here's the graph has been sketched.
Okay.
What does question say?
Okay. So when it says 2x minus 7, is that just 2 over 7? Well, which one's 2x minus 7 and which one's...
So the red line is the g of x.
Oh, which is... Okay, so that one's 2x minus 7.
Yeah, that's a straight line. The x squared one is the curve.
So is it wanting what 8x minus 12 minus x squared is greater than when it's greater than 2x minus 7?
Yep. When is the curve greater than the line?
Would that be on the left of the graph, right?
Let's see. So I suppose we need... Did this graph tell us the points of intersection? Don't think it did. That's not very good. Let me exit that. I have to delete these two. So we want 8x. Oops. Minus 12 minus x squared. We also want 2x minus 7. Okay. Shift graphical solve point of intersection. So 1. So that's for that one x is 1. And then for the other one x is 5. I really should have put that in. Absolutely should have put those in. Okay, so for what x values is the curve greater than the line?
Would it be... Would it be x is greater than or lesser than?
You tell me. Where is the curve higher up than the line?
Well, 1, isn't it? That's when it's greater. X is 1 when it's greater, right?
Well, they're exactly the same when x is 1. That's where they cross over. So
would it be when x is greater than 1? No, x is lesser than 1.
It would be, so it goes higher than the red when x is greater than 1. When does it go lower than the red?
At 5.
Yes. And so it is greater than it when x is between 1 and 5.
Okay.
So, yep. When x is between 1 and 5, the curve is greater than the line. The y coordinate of the curve is greater than the y coordinate of the line.
Okay.
Any questions about that?
So, when it comes to these graphs, quadratics and linear, like together, you have to base it on like the height of it crossing over.
Yep, you'd say
Because with the linear it's either left or right, but with this it's up, like going.
correct. So we did it in terms of x, so x is between those, but the difference is with a curve, it started down low, it went up high, but then it went back down low again. With a straight line, it would just keep going up.
Okay.
A curve, has a turning point.
Okay.
I think that's what that's about. Okay, let's see this one. This looks similar. Sketch the graph. That says use an algebraic method to find the points of intersection. And then you do that one. Okay, that's all right. So they do sometimes want you to use algebra to find what we did at the start.
Okay.
So what would you give yourself for that?
What were we, a half?
I think I might have put some stuff a bit weird. Oh, we'll see. I think this is what we were just doing. I might have put it in the wrong spot. Maybe that's why. Okay, how do we do this thing? Y is greater than or equal to -2. Let me go back. So I'm going to do... You start by doing y equals -2. Do you know how you'd draw y equals -2?
Would it be just y? Would it just be -2 on the graph, and then just the line going straight up?
Straight across.
Oh, across, and then x is straight down.
Yeah. A 5 on the x-axis.
Yeah.
This one is -2 on the y. That's 5 on the x. And how would we sketch y equals 3x plus 2?
Would it be? Well, could you just write it as y equals 5x?
That would have to be 2x. These aren't, they're not both x, so you can't combine them.
So would it be at 3 then? Would the y-axis be +2?
Yeah.
So it'd be 2 and then, yeah, okay.
And it would be a gradient of 3. So it might look approximately like that. So this is my sketch. I don't know how accurate this is. Hopefully, I don't know. And I think I need to extend it. Maybe that's what I need to do. And what x is greater than 0. Well, let's just put these together. So what I think we should, the way I usually do it is I delete the bit you don't need.
Okay.
So y is greater than or equal to -2. So where is y less than -2?
When it's just, would you have to write it as an inequality?
No. So here is the line y equals -2. Where is y less than -2?
Anything below that?
Yeah, so that's the bit we delete because we need y is bigger than or equal to -2.
Okay.
Okay, x is less than 5, so delete x is greater than 5. Where would that be?
Far right.
Yeah, to the right of the x equals 5 line. This is y is less than this line. So we want to delete all of the y that's greater than 3x plus 2.
Is there anything above that then?
Yeah. Anything above that line. And so, what region are we left with? Or actually, there was a x is greater than 0. So we have to delete anything that's less than 0. And so, what region?
So would it be written as inequality?
No. Shade, what region remains?
What, the one in the middle?
Yeah, that's it. And so that's our region there. It kind of makes a trapezium shape.
Yeah.
And they might sometimes say label the region R or something like that. R for region. And so it's that in there.
Okay.
There we go. This makes that trapezium shape. So sketch the lines of equals and then delete the bits you don't need.
Okay.
Okay. Let's see. I just want to see if there's one that's already drawn. So this is an exam question that's already drawn. Oh, it's tricky though. Oh, that's working in reverse. Man. Okay. No, let's just jump to it. Okay, points of intersection. How could we find the points of intersection of the graphs?
Can we just put them into the calculator?
Yeah, hang on, that's an insane question to start with. Let me see this. Man, they're just not joking around at all. See, it doesn't help when they don't give me any. Yeah, okay, this gives me a little thing to work with. Okay, how about this one?
Okay. So we substitute x into it first for both of them.
Yeah, you could do that.
So y equals 2 and y equals 6.
Y equals 2, y equals 6. Yeah, and in fact, you can kind of look at it and see that that's what it would be. So, 1, 2, 1, 6. Okay. And just by looking at it, any other points of intersection anywhere where they cross over?
3, 4. Well, the intersection.
Yeah, so those, they didn't specify which ones. So, okay. And so what inequalities represent this shaded region? Any idea about that? So this is like working in reverse. They give us the shaded, like the region. And we have to say what ones it would be. So in terms of, let's say, the line, x equals 1. Is the region to the left or right of that line?
Right.
And so that would be x is greater than 1. Let's say in terms of black line.
So be x is less than 3. Because it's behind the 3.
Yeah, just do it in terms of the lines they've given us. So for this line, the black line, what would that be? So it's like above the black line.
So would it be x is greater, x plus 1 is greater?
Yeah.
Would that be right?
X plus 1. How would you say this? So it'd be like it'd be what y is greater than x plus 1. That's how you'd say that. The y is greater than x plus 1. And for the other one?
1 is less than. Would it be 1 is less than?
Y is less than.
Okay.
Y is less than?
For the red line.
Yeah.
7 minus x.
Yes, that's it. The y coordinate for the red line is less than 7 minus x. Yeah. Let's take... Oh, well, I don't have the answer. But that's it. Not easy. Any questions there?
No.
So the rest of them want us to draw these graphs. Oh, this one gave me... Yeah, I like when they give me the graph. Okay, let's try this.
Okay.
Let's start with question B, just 'cause it's similar to what we were doing. So the line is 10 minus 1.8x. And then this weird curve is y equals 2 root x minus 3.
Okay.
Okay, so how can we get this R region?
Okay.
Inequalities for that.
So each point where it intersects is an inequality, so there'd be 3, right?
Yeah, 3 inequalities, 3 lines.
Okay. So it would be y is less than 2 root x minus 3.
I believe the region is above that line. So the
So it'd
y,
be y is greater than 2x
yeah,
root minus 3.
yeah. What else could you say?
Y is less than 10 minus 1.8x.
Yeah. And then they don't tell us about this L.
Yeah.
I think you would just call it x equals L or something.
So it'd be x is greater than L.
Yeah. X is greater than L, if that in fact is x equals L. Oh, it was 2.25, was it? So it's greater than that one. It's less than that one. 2.25. Oh, we had to find that. Okay, because I didn't read part A.
Okay.
So it was x equals 2.25. So greater than 2.25. And actually hold the phone. Greater than or equal to. Greater than or equal to. Greater than or equal to. Hold on. There's a good reason for that, I think. If I go all the way back. If it's a dotted line, it's greater than or less than. If it's a filled line, it's greater than or equal to, less than or equal to.
Okay.
It seems like they used the filled line almost exclusively. Oh, I hate these things so much. It's just not easy to do on the computer. And I think I'll bring in some exam questions for this. I took the book's exam questions, but I think they tend to give you a little diagram to begin with. Those ones.
Half.
So you got it in the end.
Mm-hmm.
Let's see. See, they want me to do more drawings. So they want you to sketch this. Okay. Yeah. Oh, okay. Let's do. What is this one? Set of inequalities that represent the shaded region. So we have x plus y equals 4. We have uh, 2x plus y equals 0. And we have the curve. And so what inequalities give you that region?
Okay. So it'd be y is greater than 2 minus 5 minus x squared.
Let's see. Y is greater than... that would be if the region was over the curve.
Should be less than.
Yeah, so what is it?
Y is less than 2 minus 5x minus x squared.
Yeah. So that's one of them. For the other ones, let's make it y equals for the other two, what would they be?
So would you just, for the red one, you just minus y on both sides?
For the red one, minus 2x on both sides, because it's already...
Oh yeah, okay. So it'd be y equals minus 2x.
Yeah. And the other one?
And then the other one would be, you just put minus x.
Mm-hmm.
So it'd be y equals 4 minus x.
Yeah, and so use that for the other two.
So it'd be what y is greater than minus 2x.
Mm-hmm.
And then the other one would be y is less than 4 minus x.
Yeah. And actually, I just realized maybe we didn't need to rearrange it. Maybe we could have just said 2x plus y is greater than 0 and x plus y is less than 4. I don't have the answer, but yeah, that would have worked as well.
Okay.
Okay, so that's good. I just need to... am I missing some questions? I brought these in. Silly me, silly me. I think, unless there weren't any, this is 3.7. 3.7. That is pure one practice. So there's an additional thing that has extra exam questions. Regions. Nope. I just kind of put them in weird. So those go in 3.7. That's why. So I put them in kind of... I put them in the wrong place. That's why they kind of suddenly jumped in.
Okay.
In difficulty. Alright. We better sketch this stuff. So let me go all the way back. Okay, how do we go about this one?
Okay. So, would you make them equal to each other first?
Yep.
So it'd be 7 over 2 x minus 31 over 2 equals x squared minus 3x minus 10.
Yep.
And then you add 10 to both sides. Which would be,
Hang on. You've got 3 things on the right and 2 on the left.
so is it better just to from the left to the right then?
Yeah.
Okay. So you'd minus 7 over 2x from both sides, so it'd be minus 7 over 2 minus 3, which would be minus 13 over 2x.
Yeah.
So it'd be minus 31 over 2 equals x squared minus 13 over 2x minus 10. And then you add 31 over 2 to both sides. So it'd be 31 over 2 add minus 10, which would be 11 over 2. So it'd be x squared minus 13 over 2x plus 11 over 2 equals 0. And then you'd put that into the calculator.
Yeah.
So it'd be 1 minus 30. Well, let me put a fraction into the polynomial. Should I just switch over to a decimal number?
It'll still work. That one, if you do minus 13 and then press the fraction symbol, you'll just get a different symbol, but it's the same idea. So it's minus 6.5. Yeah, it still figures it out. Or you can use divided by instead of over.
Okay, so we have 1 minus 13. Okay, and then 11 over 2. 11. Which would be x1 is 11 over 2. And
okay.
x2 is 1.
Equals 1. Okay. Question B, you have to sketch the graphs. Any idea if you'd sketch the graph?
Well, we know that both of them are positive numbers.
Yeah.
But they're both roots.
Hang on, I'm not worried about that for the moment. I'll deal with that another time. Question C. Coordinates of the points of intersection.
So would you substitute x1 into the equation?
Yep, which equation?
P x.
Yeah, either of them will work. P is easier.
Okay. When you do that for both of the x's, right?
Correct.
Okay. So it'd be 7 over 2 multiplied by 11 over 2. 2, which is 77 over 4. And then minus 31 over 2. So for x1, I got 15 over 4.
Mm-hmm.
And then x2, let me sub that in. 7 over 2. 1. And then minus 31 over 2. And then for x2 I got minus 12.
And so coordinates?
Oh, so for the first one, would it be 11 over 2, 15 over 4? That'd be right.
Yep. And the second one?
Minus 12 and 1. Well, it'll be 1 and then minus 12.
Yeah, 1 minus 12. So just making sure about that.
Yeah.
And let me just see this one. 7 over 2x. So you'll see there it said use an algebraic method. And so even with a graphical calculator, you can check your answer. But if you used it entirely, you'd get, it says in the mark scheme, no working, no marks, which is cruel. But there you go.
Okay.
I'm just keeping it short. So that's what it looks like. We want question D. P of x is less than Q of x. No, I don't need to make that. I need to do like that. Where is the P of x less than the Q of x? Where P is the line, Q is the curve.
Okay. So which one do you know is... Oh, wait. Which one do you know is P of x and which one's Q of x?
So P of x was the line.
Okay.
Q of x is the curve. Where is the p of x less than the q of x?
Would that be when x is greater than? Would it be x is greater than?
Depends.
Greater than 1?
That is when the line is higher up than the curve. We want when the line is less than the curve.
So could it be when x is greater than 5.5?
It's when x is greater than 5.5 or
x is less than 1.
Yes. So like quadratics, you get two answers. It's just
Yep.
with the other ones, if they had said when is the p of x greater than, we could combine the two together. Greater than 1, less than 5.5. So when x is between 1 and 5.5, here we can't combine them because it's outside. When x is less than 1 or when x is greater than 5.5, that's when the first equation will give you a number bigger than the second.
Yeah.
And do I have the answer? I do. X is less than 1, x greater than that. And this is this set notation. So x is less than 1, x is greater than 5.5. So you do x colon. It's not a ratio.
Yeah.
The other one, same thing. X colon and U for union. That's like or.
Yeah.
That or that. If it was in between, it would be the and symbol.
Yeah.
Any questions about that?
No.
It's getting good. I just had to go back. Shade the region that satisfies this inequality. So let me try something here. Calculator. So first one, x, I'm going to do equals for each of these. X equals x minus 2. Y equals 4x. Y equals 5 minus x. And so you have to shade the region. Let me move it up a bit. That looks all right. So copy, paste. So I put them in the order that they came in.
Okay.
Well, hang on. I'm not sure myself. So it goes blue, red, green. Okay. Okay, how do we do this?
So we eliminate the sections that are not.
Well done.
Okay. So anything greater than x minus 2 should be eliminated.
Should be kept.
Kept.
Yeah.
So anything more than, less than.
Yep. Anything less than x minus 2 should be
Taken out.
yes. And so where is that on this graph?
Is that just under the blue line?
Yes. So we delete everything under the blue line.
Yep.
Okay. Next one.
So we get rid of anything that's more than 4x.
Yeah. Which one is that?
Is that anything on the left of the red line?
Yes. Anything above the red line, I'll do it as.
Okay.
It's the same thing.
Yeah.
Yeah.
And then the last one is anything if y is greater than.
Yeah.
Anything greater than 5 minus x, which is above the green line.
Yes. And so we're deleting above the green line. And so
Okay.
what's the region remaining?
It's a triangular shape in the middle.
Yeah, and so they wanted me to shade that region.
Yeah.
And so I'll do something like this. Yeah. And did they say like label it with letter R or anything like that?
No.
Just shade, was it?
Yeah.
Okay, so we shaded that region. I'm gonna call it R. Oh,
Okay.
I forgot to put my thing back. Region R. There we go. And okay, I don't have the. Oh, I do. I forgot something. I can actually on this thing. Just want to see, is it too late? Type. Let me press right. So this is y is greater than. That's F1. Oh, is it too late? I have to start again. Do I? Hang on. Type. That one is F1. So that becomes y is greater than. What does it look like? Oh, no, it does work. It does work. So the second one was y is less than. So type right less than, and then y3 is less than or equal to. Type right less than or equal to. I have that as well. Let me press equals. Oh, I didn't do anything. Maybe, I don't know. All right. Any questions about that?
No.
Okay. So this one looks real difficult. Real difficult. We better do it. Let's see. All right. So how do we go about this one?
Okay. Would you put the black lines one into the calculator?
If you do that, that gives you where it crosses over with 0.
Yeah.
You know, you're onto something there, actually. I think you've... Yeah, well, maybe you don't want to assume that, but
The other one
those
has no roots.
two cross over when at that root, and that crosses over at that root. So that's not as difficult as I thought. There is that one and that one, but that looks like when y is 0. No, that's when y is 0. Sorry. No, that's when x is 0. So the root. So this one actually isn't as challenging as I thought it would be.
Okay.
So I thought you would have to combine these two and solve it. Then you'd have to combine these two and, solve using calculator. And then you'd have to combine first and last and solve using calculator. But actually, you're right. So this one, the y-intercept, when x is... So for these, when x is 0, what y do you get?
Plus 2.
So one solution for all of them is 0, 2. And then the other solution is going to be something 0 and something 0. And that something will just be when you put the black one in the calculator. So that's actually not as bad as I thought it was. All right. Let me just make sure. Go back. Okay, I want to recap this thing. So in general, you've got two functions, f of x, g of x. Let's say they cross over at 2 and 5. So for this one, when is the f of x greater than the g of x? When is the curve greater than the line?
When x is greater than 5.
Any other time?
When x is less than 2.
correct. It was under the black line, but then here it becomes over. What if the question was solve the f of x is less than the g of x?
So then would you just substitute 5 and 2 in, or would that be wrong?
You can't really substitute. We don't know the functions. Where is the curve less than the line, lower down than the line?
Between 2 and 5. Oh, so it'd be 2 is greater than, is less than x, and then x is less than 5.
That's it. And another way to say it is to just flip these two up here. It's when x is less than 5 and x is greater than 2. But, but those two can be put together. So bigger than 2, smaller than 5, so between 2 and 5. And I suppose one more thing. When is the f of x equal to the g of x?
Would those just be the two intersections?
Yep.
So that'd just be... well, we don't know what y is.
Don't need it. Just in terms of x.
Oh, so x is 5.
Any other?
And x is 2.
Yep. And so this is kind of what we started off with. Equations, which we all love. And then it becomes inequalities, which we all hate.
Yeah.
Curve is greater than the line when x is bigger than 5, when x is less than 2. Curve is less than the line when x is between 2 and 5. And that's kind of what that's all about. You have to find the intersection sometimes. You have to sketch the graph sometimes, but that's what it boils down to. And that's the end of chapter 3 anyway. So what do you give yourself for that in general?
Like the whole of chapter 3?
Yeah, let's say whole of chapter 3.
Probably a tick. I found most of it easy.
Yeah. And sketching graphs is just kind of it's kind of limited with the computer, but I do my best. And so how was that for you, Adam?
That's great.
And so chapter 4 next time?
Yep.
Okay. Any questions for me in general?
What's the first chapter? Not chapter, topic, subtopic.
Let's see. Chapter 4. Wow, I went fast. It's graphs and transformations. It starts off with cubic graphs. So we were doing lots of quadratic stuff.
Okay.
Now we've got cubics, which are 3 brackets or x cubed, basically.
Okay.
Anything else? Any other questions?
No.
All right. Well done, Adam. You did great. I look forward to chatting again next time.
You too.
Thank you. Take care. Goodbye.
Bye.